So when we're talking about the nature of roots of a quadratic equation, we are trying to find out, not from solving the entire equation, but from a special formula which we're going to do now, we're trying to find out the nature of the roots. So what kind of roots are we going to get out? Okay, so the first thing to understand is this word roots. When we solve a quadratic equation, we get our x answers out, and we normally get 2 of them. So for example, x equals 2, x equals negative 2. Those are the answers. The roots is another way of talking about the answers or the x values of a quadratic equation at the end once we've solved it. So for example, if we had those 2 as our answers, then the parabola, if it was a positive 1, would look something like that. So it would be your 2 x-intercepts. These 2 intercepts can easily be drawn in a graph, but sometimes they can't. Sometimes, as we found in the previous chapter exercise, is that you get non-real roots, so you get ones that can't actually be plotted on the graph. So we can get to that quite quickly by finding out what the nature of the roots is without having to go through the entire process of finding the answer and the solutions to that particular quadratic equation. What our special formula is going to be able to tell us is whether the roots are real numbers. They could also be non-real. Also, whether they are rational or irrational. And we can also get roots that are equal to each other. Okay. For example, when you get out, say, x equals 2 and x equals 2, you get 2 roots that are exactly the same, meaning your parabola, if it is positive, would have 1 x-intercept. Okay, so a few reminders of things you would have done in grade 9 and 10. You will probably remember that if you have the square root of a negative number, whatever it might be, that is non-real. Remember that when we used to fill in those tables and tick the boxes about what kind of numbers various examples were, these ones and things over 0 were the non-reals. Okay, so that's the first reminder. And then, if you have the square root of a perfect square, so say the square root of 9, you're going to get out a perfect answer. It's going to be very, very rational. It's real. Okay, so I'm just going to pop those things down. It's rational. It's also real. Okay, and then you'll remember that one of the ways we classified irrational numbers is if you had the square root of a number, it's not negative, but it's not a perfect square. So this is going to give you something with a whole bunch of decimals, and that makes it a non-terminating, non-recurring decimal, which makes it irrational. Now, you remember the quadratic equation, right? So that was negative b plus or minus the square root of b squared minus 4ac, and that was all over 2a. Okay, so if you've got an equation of the form ax squared plus bx plus c, you've got a b value, you've got an a value, it could be a fraction, but it's not going to be an irrational number. So b and a, if they're inside this fraction, you don't have to worry about those. If you divide whatever b is by whatever 2a is, you could get a negative number, you could get a fraction. This whole thing is going to be rational. The issue is going to be what is under the surd sign. And that is heavily related to what I've just reminded you of from grade 9 and 10 work. If this thing is going to give something that's non-real, we're going to have roots that are a little bit iffy. And here, again, we'll have roots that are very clear, and here we're going to have irrational roots. So basically, these two are the ones we don't need to worry about. Our special formula is merely using this section of the quadratic formula to establish not the roots themselves, but the nature of those roots. Okay, so here's the theory that you are going to need to learn off by heart to be able to use when you work this out. So if delta is positive or 0, then you've got something that is going to give you real roots. Okay, so here the roots are real. I'll come back to delta being 0 in a moment. So you've got real roots if delta is positive. Okay, if delta is negative, you therefore have non-real roots. So those would be ones you can't actually plot because they're not there. Okay. If delta is a perfect square, then you're going to have rational roots. And if delta equals 0, we already know it's real, but something quite special happens when delta is 0. Then we have equal roots. Okay, so that is real. This is non-real. Rational is that, and equal. When we answer the question then, what is the nature of the roots, we are going to end up using a combination. Obviously, if they're non-real, there can't be anything else. But if you've got real roots, they could also be rational, and they could also be equal. So what we always put down for our answer when we're asked what is the nature of the roots of this particular equation is we work that out, and then we can get whatever these ones qualify, we will write down and say the nature of the roots is rational and equal and real, if, for example, that works out that way.